Good morning, and our giant for the scientific revolution is Andreas Vesalius, presented by Aiken, Cade, and Jaden. So some of the quick basics of his life is that he was born in Habsburg, Netherlands in 1514 and died in 1564. And where his contribution to the scientific revolution really began was in Paris during his study of medicine. And this is important because that was where he was introduced to the works of Galen. More on Galen, it was one of his works actually, the rediscovered on anatomical procedures that led Vesalius to emphasize the use of practical research or a more hands-on approach. And this hands-on approach was used as an avenue to understand human anatomy as well as disprove some of Galen's assertions about the human body. More on that later.
Okay, so major works. First is the Tabulae Anatomicae Sex, and this was just a set of 4 posters that depicted the human body. We see one right here that he created when he was a lecturer at the University of Padua. Now, the second one is what he's really known for. It's the Humani Corpus Fabrica, or On the Fabric of the Human Body. So it's actually a set of 7 books. Each book discusses an important aspect of the human body. So there'd be a book on the brain, book on bones, etc. And what's important to note is that the information contained in these books are actually derived from first-hand dissections that Vesalius, for the large part, conducted himself. So this allowed him to gain an at least somewhat accurate understanding of human anatomy, and he would use this information to develop relevant theories about how the human body functioned, which would really be an important breakthrough in medical science. So next, we have the primary source. It's an excerpt from The Diligence of the Maker of Things in Creating the Thorax. And this is part of the fabric of the human body. So first he poses a question. Would excrement be set aside, or how much offspring be expelled and fit for labor could happen if no muscle rendered assistance here? And now he starts with this strain of reasoning. So first he says, well, if the thorax is only bones, there's going to be no movement at all. So the thorax is not going to work. On the other hand, if it's only muscle, there's not going to be any structure. So the thorax also isn't going to work. So he draws a conclusion. In order to have some inner thoracic capacity and for the thorax to be moved voluntarily, muscles are placed alternatively between the ribs. Now, this would actually be an example of inductive reasoning. He has the conclusion. He knows this is true because he's conducted these dissections of the human body, and now he's going to try to figure out why this is. And that's where this reasoning comes from. And this is the type of reasoning, this kind of logic based on facts, or facts derived from logic, that'd be deductive reasoning, that would characterize the scientific revolution, where people focus on trying to gain a real understanding of the human nature.
Vesalius made an impact by teaching future scientists like Gabriel Falloppio, who specialized in the anatomy of the head and eventually went on to discover the fallopian tubes. He also proved a lot of Galen's ideas wrong, which was huge at the time because no one really challenged his ideas before. He normalized using human dissection for the purpose of making discoveries about human anatomy. He found new ways to explain systems. For example, he was able to completely describe the muscular system, and he was able to name every muscle in the body and its purpose. His images and descriptions of the human body helped pass on his ideas to future generations. He also promoted the idea of researching for yourself rather than solely relying on the information of past scientists. And because of the impact he made on science, he is known as the father of modern anatomy. He also proved that humans and animals were different, and you can't just dissect an animal and apply the evidence you find to a human. Thank you for watching.